Before I get started with tonight's video, I'm just going to announce a little policy change. Going forward, I'm not going to answer your questions regarding problems with your equipment in the normal channel. I'll answer other questions, but I'm not going to do any technical questions. For that, you're going to have to be a Patreon member and ask me through the Patreon app. Then you can ask all you want and I'll give you my full attention. But I just don't have time to answer every question that comes in on the forums. Got an old Grundig Type 1055 W3D in for service. As you can see, seen better days. Someone's damaged this unit, but this unit was in at another shop that gave the owner of this an estimate of about $360 to fix it. As he put it, he likes it, but not for $360 to repair it. So I'm going to take a shot at it and see whether we can get this thing working a little more reasonable than that. So I haven't turned this thing on yet. I'm not going to plug it in until I inspect and check all the capacitors and stuff, because it's a vintage tube radio. You just don't plug them in before you recap them. Looks like this unit may have been dropped at some point, because that crack goes all the way through the base and up the front. The first thing I do is I inspect before I do any work. So we have documentation that this is how I received it. So I'll start by removing the chassis screws. We'll remove the chassis. 4 screws removed. The radio itself will just pull out. Just gotta take off the light bulb here. And what else needs to be unplugged? Probably the speakers. The speaker wire here. This wire here goes to the Magic Eye tube, which we'll just remove. It's just held in place by a spring. This is for your tuning eye. I even think I have one of these tuning eyes, kicking around somewhere. Okay, should be able to turn the chassis around here without disconnecting it from the speaker. So we need to replace these capacitors here. These ones here are going to go bad on this. These blue ones here, these ones are notorious for going bad, as are paper capacitors, such as this one here, and this one up here, and this one over here. Probably this one down here too. So I have to replace these paper condensers first before I even attempt to power this up. This unit uses a selenium rectifier over here. So this selenium should be swapped out for something a little more modern, as these have a tendency to go bad. And when they do fail, they can fail violently. But let's start by changing out some of these capacitors first before I even try applying power to this thing. I want to make sure that I've gotten the paper and these type of caps that go bad. These ones here swapped out. These are going to get swapped out before I even apply power, because at a very minimum we've got to get those old capacitors out of the circuit, because they're bad news. And with these in here, what happens, and we've gone over this many times, and others have gone over this as well, but what happens is the paper, these are paper wrapped capacitors, and the paper starts to break down after a number of years and becomes electrically leaky. And once that happens, the capacitor is designed to block DC from getting from the plate from one stage to the grid on the next stage. And when you have a bypass capacitor that's failed, you could end up with your plate or a voltage leaking through and causing an overbias on the next stage. Same would happen if one of the bias resistors were to go open and you lost your bias. Will cause the tube to go, or can cause the tube to go into full conduction and damage the tube and or transformers and coils in the next stage. So it's pretty important that these ones get swapped out before attempting to power the unit up. So I'm just going to go grab my capacitor kit here, and we'll start replacing a few of these ones and see what happens. So I'm just replacing the first cap here. I'm going to put a little hook on the end of the wire. I've already put the one side of the cap in. It's hard to see this one because of the shield that's in the way, but get this one down in place. I'm just going to solder it back onto the original wire that was attached to the chassis, just because it'd be a little easier than trying to heat the chassis up to solder right to the chassis. I need an iron that's got a little more power than this one, so I just clipped the wire and soldered it onto the end of the stub. So that's the first one. Changed. We're also going to change this next one to it, which is a point 0.1, 250 volt. Well, I'll go a little bit higher voltage than that, but here's the next one. And see, these type here also give trouble, so they need to be replaced. And the nice thing about these old vintage radios is that they really don't care about capacitors, right? I mean, you'll get some audiophile stuff where people just get quite specific about, you know, certain brands of capacitors and stuff for their high-end audio gear, and they can get quite fanatical about it. But when you're dealing with this vintage stuff, it's really not as big a concern. There's a lot of room to experiment, let's just say. You can change values of parts, and it really, as long as you're close, because the tolerance of a lot of these old components were you know, in the 10-20% tolerance specification, so there's lots of room for error. As long as you're, you know, if it's a 0.1, you put a 0.1 capacitor in there. But there's lots of room to change things slightly if you have to. With these ones, you got a lot of leeway, just because of how these things were designed. These old components themselves were not real high tolerance devices. So I'm just putting the heat shrink tubing over here to insulate the wire, and we'll reconnect it here. Going to heat it up and put it through the hole in the mounting lug here. Like that. Then the other side goes back down to the ground wire. Okay, I don't have a 1500 picofarad, but I've got a 2200, which should be close enough. This is just at the tone control anyway, right? The tone and the volume control, so it's not really going to make much difference in the way that the unit operates. I can just hear it now. Someone's gonna make a comment about me using electrician's scissors to cut the wire off, and why don't I have side cutters? I do have side cutters. I have several pairs of side cutters. Look, see, I've got side cutters. I got more pairs of side cutters than I know what to do with them. Got another pair here. You see, I got all kinds of side cutters. So why do I use the electrician's snips? Here's another pair of side cutters, just for you guys that just wonder why I don't use side cutters. Well, it's just that I get used to using these ones, and they're very sharp, and I can get right in there and nip it off, and it cuts the wire nice and clean. That's why I use a good old Klein electrician snips. It's just, this is what I've been used to using for years, and it gets the job done, and I can get in there and cut it very, very fine, cut it very close, and it's a very clean cut. That's why I use them. It's called personal preference. Okay, that's 4 of these little buggers replaced. Let's get this next one here. This is a 0.01. So let's do that one next. Let's find a 0.01. 0.01. There's a 0.01 right there. Something tells me I'll be making another trip down to good old Lee's Electronics and picking up some more caps because I'm getting low again. But look at how this one was put in. This one here is looped all the way through. This is actually a coupling capacitor, this one here. So this is a critical one because a failure of one of these, if these ones go leaky, that will cause failure of the unit itself. Okay, that part's in place. And the other side of this capacitor goes over here to this terminal. Okay, that one's in place. Now to retrieve the little wire I cut off. That's that one done. I've got a couple of electrolytics in here that are going to be kind of fun to reach. These big ones here are going to be fun, and they got to be changed too because they're going to be bad. But I'll probably just string them across the top here. I don't need to get them all the way in where they were before. I'll just cut that one out now. You can see that this electrolytic is the insulator on the top is coming out. So let's just cut this one out. These are like 15 volters, so no problem changing them out with something more modern. But as you can see here, if we look at the top here, the electrolytic in here is going to be completely dry. This is a 50 microfarad, 15 volt, so I'll put like a 47 in place of it. But this is going to be completely dry, this one. If we just look at the seal is coming right out on this thing. It's just all crumbling. Right, so this one's definitely going to be completely dry. As you can see, there's nothing. Normally if you squeeze an electrolytic capacitor, the electrolytic will come out. This one here is just completely dried up. So let me go find one. Yeah, I've got the new one hanging in here. I'll have to probably extend the negative lead a bit, but we'll get the positive lead soldered down first, right in here. Okay, the negative lead I've got poking down here underneath the chassis. See if I can get it to a place where I can attach it. Okay, that's one done. One electrolytic done. The other one is also going to be a fun one. It's over here. So we'll do the same on that. I'll cut that one out and fish another one in there. This one's a 4 microfarad at 80 volts, so I'm sure I can find a 4.7 at 100 volts or better. Positive side is actually connected down to the chassis on this one. Negative side was up to this tube up here. To bend the wire out of here to make sure it's not going to touch anything else, right? And then the other wire comes down here, the positive side comes down here. Now what I've done on this one, I didn't have a 4.7 at 100 volts. So what I've done is I put two 10 microfarad in series, which gives me 5 microfarads, which is still going to be close enough for what I need, but it gives me the voltage that I need as well. And of course, with electrolytic capacitors or any type of capacitors, if you say put two identical values, like two 10 microfarad in series becomes 5. If they were in parallel, it would become 20. And if you put the two negative terminals together, so you solder your two negative terminals together, you turn it into a bipolar capacitor or a non-polarized. In this case, the positive of one goes to the negative of the other. So the positive of the first 10 microfarad is to here, the negative it is connected to the positive of the second 10 microfarad cap, and then the negative of that is soldered down to my tube socket here. And I just make sure that nothing's touching, none of the wires touch. I put heat shrink tubing on the connection between the two of them, so there's no risk of anything shorting here. And I just make sure that I've got a proper bend radius here so that nothing's going to touch. Everything's good. That shouldn't be any issues. So that's the two electrolytics replaced. Now I've got to do I think this one here is going to be changed, and these two more back here. And I think that's it for the cat. Oh, this one in here as well. And that should probably do it. And then I can test this thing out. As you can see, this one here is not even connected. I think it goes to here. It must, but it's not even soldered down. That one there is, that one's right open. But that I'm pretty sure it went to there. I didn't take anything off, so it's got to go to that terminal. I'm thinking. I'd have to get the manual out to double check that, but and that's in the audio output stage too. That cap. So we'll just take this one out of here. Okay, this was a really low value cap, so I've just replaced it with another little ceramic cap in here, which is a little bit higher in value, but again, it shouldn't make any difference. The tolerances on these old tube radios, especially in the audio output, are quite high, so you can get away with changing values and going up a little bit in capacity, and it's not going to really make much difference as long as you don't go overboard and put in a really huge one. Yum. Tell you, these little flashlights I got are great. These little LED lights that I got from Banggood to evaluate. I use these things all the time. They're great, rechargeable. Just use that cell from that $4 battery pack, and the things just go forever. Okay, that one's done. Just making sure there's nothing touching. Everything's looking good in here. Got one more here, and one more down in the can here. Okay. I think that has all the critical caps have been changed out on this one. So we've changed that one and this one down here and this one and both of these electrolytics down there and there. That one, that one, that one, that one. I think that's all the ones. I'm just going to go over it a second time and then we'll try powering this thing up and see what it does. Ready to power this unit up now. I have it on my big dim bulb tester, which is basically a 100-watt incandescent bulb that's in series with the power cord. So if this thing draws too much current, it's not going to burn anything up. So I'll turn on the switch and see if anything starts to light up on this thing, which I don't see anything. I don't even see the light lighting up here. Normally these units, you just, that's off. You just switch the band on that you want to use, UKW being the FM band. But I see nothing on my light bulb that indicates this thing is drawing any type of current whatsoever. So I'll have to just take a look and see if they're getting any power into the main rectifier. My meter in AC mode, and we have nothing coming off the transformer. No power. So let's just check to make sure that we actually have power getting to the transformer. First we'll check the fuse, which I just removed from here. Here's our fuse. It doesn't look to be blown when I look at it. Aha. The fuse is blown, because that should beep, right? Fuse is blown. Interesting. Take a look at the fuse. This looks to be a slow blow fuse, but it doesn't look to be blown. Normally when these slow blow fuses blow, the spring pulls the circuit open, because how a slow blow fuse works is it has a type of resistive element that heats up, and when it heats up to the melting point of the low temperature solder that's in here, the spring opens the circuit. But this one here is open. Very interesting. Calls for a 0.6 amp fuse, which I don't have, but I do have a 0.5, so we'll try that. The next one I have is a 1.6, so this shouldn't blow. It shouldn't draw anywhere near that power. 420 volts, it says. It's a 0.6 volt slow blow, 0.4 amp for 160 volts, and 0.3 for 240 volts. It might kick the fuse, but it might not. We'll try it, see if it pops it or not. Let's just turn on the power. And hey, what do you know? We got power. Lights up. The lights are coming on here. It may have been one of those caps was shorting out and it drew too much current and tripped that fuse, or just the fuse went bad on its own. But we have power lighting up here on this thing. Let's just see whether we get any volume out of this radio as it warms up. Magic Eye is warming up. I believe we have sound. Yeah. There's no antenna on this thing, so I don't know which one of these is the antenna terminal. One of these is going to be AM and one's FM. I'm sure.
Depth journey September.
I don't know if I can tune my test unit in or not. Sounds like my test transmitter. Here we go.
Smoothies while eliminating the things you don't want. And by the end of 2018, we'll be blending over 50 purpose blends with no sugar added. Because our goal is to help you achieve yours. Track our progress at smoothieking.com/cleanerblending. Smoothie King. Smoothies with a purpose.
classic rock 92.9 KISM.
Are you ready? Yeah!
The most non-stop classic rock starts now.
Rock and roll!
Do it. On 92.9 KISM.
One cars behind the turbocharged engine that powers your soccer practice car.
My local program.
We sure picked a great week to go camping, honey. What should we do?
Binge watch?
What?
How? We've got one.
Sounds like it's working to me. Let's try the AM band out and see how that one works. Now that'll be this medium wave band here. I don't have an antenna on this thing either. Let's see if I can just clip something on that wire.
Long way.
Very true. And when you shop with us,
My test transmitter. Tone control.
Stones.com. With us,
You won't pay more.
but you will get more.
If I take the antenna off, of course.
For that incredible one.
I'm just holding a wire to the back here, right?
Appliances Gene White clearance event is on
So I'm not putting much of an antenna on there, and as you can hear, this thing is pulling on everything.
sales on brand name made
That's the length of the antenna. It's like a foot long.
clear out.
Even without an antenna.
Dishwashers, laundry,
Still picking signals up.
all their
These old Grundigs were actually pretty darn good radios, you know. I mean, I've always loved these old Grundig radios. They're just German-built, fantastic receiver. Now, I'm not going to obviously say the name of the shop that told this fellow that it was going to be $360 to replace a handful of capacitors and a popped fuse. But they are well known in Western Canada as the place to take your vintage audio. And I won't say any more than that because I think everybody will know who I'm talking about without me having to mention their name. Okay, let's put this one back together. I'm going to phone the fellow that owns this thing and he'll be tickled because, again, he was expecting this thing to have major problems. He was told that the power tube was shot. That's why it was going to cost so much money. The power tube was shot and it was going to have to be ordered from Germany. What's a kicker on this is a Rogers Majestic tube that's in here. So this is a North American made tube that was used to replace this at one point in the past. The other tubes in here, these ones look like these ones are European tubes. It looks like. I don't want to pull them out because a lot of these ones are this is the rim lock, right? So I don't want to pull it out because I don't want to risk damaging the tubes. But this one's definitely been replaced before. Anyway, let's get this thing back together. I was going to change out the selenium on this one, but it's not bad. It's not broken. You know, it's not shot. So
Delicious new chocolate chips.
I got B+. Got
Rich chocolate chips. And lemon poppy seed loaf.
lots of volume, so
Enjoy
I
this
don't think we have to worry about the selenium at this point.
Tim Hortons restaurants.
This is a Bloomberg Pursuit. Look at luxury.
But yeah, the tuning indicator tube is no good. And I might have one of these in my collection of tuning indicators. As you can see, this thing is not drawing anything in the way of current because the light itself is just barely glowing. So there's no faults with this thing. There's nothing that's drawing too much current on this radio. It's actually in really good shape. This Magic Eye actually does work. It just has to be dark in here. It doesn't give off a lot of light, as you can see.
And then started punching.
It does work. It just doesn't throw off a lot of light. And maybe it's wearing down a bit, but it does work. Cool. Always like these Magic Eyes. I think they're the neatest things. So if you want to test the Magic Eye, test the circuitry for the Magic Eye, I got the light still dimmed down here in a bit, just one bulb on. The red wire here has your B+, which is like 270 volts, is that? Or is it 200? 212 volts, okay. I couldn't see the meter with the shadow on it, but B+, it's got the two filament voltages, which you won't be able to measure, B+, and then the tuning line is this one. And if we measure this one, this is our negative control voltage that keeps that keeps the cathode suppressed. And as we tune a station in,
we know you can't make the perfect s'more until you've burnt a few marshmallows.
you can see for full-scale deflection, put 9 volts.
Like bass.
That's how they work.
And see 40%. Dollars.
Obviously, that music station that we hear playing there, that's just my test transmitter. I just got an FM radio connected to it, and I'm just rebroadcasting on 1440 for my own. Listen to it on my own radios. It's kind of cool having a little transmitter that I can play my radios on. Anyway, I just wanted to show you guys that this tuning eye actually is working. It's just with all the lights on in here, it's hard to see. Even with these lights on, it's hard to see. This tuning eye tube is just about toast. There's very, very low emission. This is a cathode ray tube, right? Works very similar to a picture tube, but instead of it shining a beam that's onto the screen that you get on a CRT, the cathode in here just shines electrons up onto this photosensitive. It's the anode, which has got the 215 volts on here, the positive voltage. And that's how it works. And when the grid goes more negative, it pulls electrons from the cathode, which then goes through the little aperture down here that throws them in a beam onto the actual tube itself. But he's going to have to source a new tube if he wants this thing to be nice and bright. I had one here. I have another one here that came out of an old radio, but unfortunately it's not the same tube. Looks the same, but the internal wiring is different. I guess I could rewire the tube socket, but I just don't know whether this thing even works or not, because this came out of an old radio that was scrapped years and years ago. I don't know whether this works, but I think it's a different number. It doesn't do anything on this, so it's probably a different number and a different pin configuration, or it might be the same, it's just that this tube might not be any good. Just kind of thread the screws in through these. There's wood standoffs on here, so it's kind of got to get the screws through here and into the chassis, and then I can tighten everything up. And then one of these days I will actually get to my Normandy, which is sitting beside me here. That's my own set. There's way more tubes in this. It's actually a little more modern, and it has a circuit board, so the capacitors are mounted on top of the board. So it could be probably a little more of a challenge to work on, because it's an early PC board, and well, we know how reliable they were. So the unit's back together. Here's the FM band again. Unfortunately, well, I shouldn't say unfortunate, but it's a typical German radio. Oh, cool! Look at this. When you turn your bass control down to bass, has a little indicator. You can hear the sound. A lot of the German radios, the older radios in Germany, the FM band was 87 to 100 megahertz. So because of that,
However you use this band.
it's going to go to 99.3 the Fox, and that's as far as you can get. You can't get Rock 101 or any of the other stations above 100, because it only goes up to 100. That's the highest one it's going to get.
LTE. So
99.3 French station. Jack FM 96.9, 96.1. The dial's working, it's accurate too. 95.3. I guess 94 point whatever it is. 93.7. 92.9 should be down here somewhere.
For the federal government.
I don't have an antenna on here, just a screwdriver sticking out of the back. Yeah, so better. Anyway, it's all fixed. The guy that owns it's going to have to do a little bit of cabinet repair because, as you can see, the front cabinet is kind of broken. But hey, it's working.
Head-turning style with the 2018 Lincoln MKC. Its richly crafted interior with standard bridge of weir leather trim seats, standard intelligent all-wheel drive, and Lincoln Drive.
That's the power off button. That would be phono input. It's got a picture of the phono. Phono input. It's got long wave. I guess it's got long wave and medium wave. It doesn't have. Does it have short wave on this thing? I guess it doesn't have short wave. It has. Yeah, it goes 150 to 340 kilohertz, and then 510 to 1600. So it's got long wave here. You go 145 to 300. It says right here, right on the bottom here. You can read it, but you're not going to pick up anything on that. Nothing down there. Your AM broadcast band.
This is BNN.
And then
Every World Cup match with 2 massive 12-foot by 7-foot HD screens.
87 to 100. That's all it gets. Okay. Thanks for watching, and we'll catch you again in the next one real soon. Bye for now.